Hey YouTube, Josh here with Tipsy Python, your casual guide to learning how to program with Python. I'm back with another video, and in today's video I got a couple goals. First, let's learn and practice how to write some custom functions. And then secondly, let's go back to that whiskey review app that we've been making, and we'll refactor it and we'll add in a feature that allows us to search for some reviews. And in today's video, I'm actually featuring the last of the Jameson trio that I picked up. This one is the Jameson Caskmates IPA finish. Now, call me silly for picking this one up, but when I order a beer, I usually get a lager or a hef or even a bock. But you know, occasionally I'm in the mood for IPA, and I'm always in the mood for a pour of whiskey. And I've never had a beer barrel aged whiskey before, so this one should be interesting. Alright guys, today's video is about functions. Now if you're coming from another programming language, you already know what the deal is. And if you don't worry, they're not hard. And if you watch the rest of the videos in this series, you already know what I'm talking about, because we've looked at the Python documentation to see the standard library functions many times. Now we're reusing that same construct, a function, but we're just defining our own. Now, very simply put, a function is just a modular, reusable piece of code that only executes when it's called. Let's get straight into the code though. Get your drinks ready, get your computers ready. I'm heading into Jupyter. The function that I've loved to use throughout this tutorial is the print function. It accepts a value and then performs an action only when it's called. Now let's try writing our own. Very simply, they look like this. Use the keyword def. I'm going to name it first func, then parentheses, a colon, a 4-space indent, and this indented code block contains logic that we want to run. In this case, I'm just going to use pass. And to run our function, we're going to call it by using the name and then parentheses, sort of like we do with the print function, and execute. And that's how functions work. If you enjoy this type of content, please consider subscribing, and until next time friends, Tipsy Python. No, I'm serious, legit, that's all there is to it, but I guess if you want to, we go through a couple more examples just to get our functional sea legs working. But as you know, a dab will do me. It turns pale on the finish. Going back to Jupyter, I'm going to write a new function. This time I'm going to call it say hello, and the action it makes is print hello. Call my function, I just call the function name followed by parentheses. And as you might have suspected here, it outputs hello to the console like we thought it would. Now, as I said earlier, the function is a modular, reusable piece of code. It can be reused many times, but it's only executed when you call it. So let's call this a few times to see how it works. The first thing that I want to do is import time to introduce some latency to my code. I'm going to make a while true loop. I actually want it to pause for a second so we can see what's happening. I'm going to say sleep, time.sleep 1 second. And then we'll call our function, say hello, and loop and start the whole thing over again. Let's see what happens when I run it. I get that this is a pretty trivial example, but imagine if we were doing more than just printing hello. Imagine if we were printing a lot of text. It would just save room in our code and make things prettier for us. And imagine if we had a lot of steps inside of our indent block in the function. If we ever had to go back and change something, instead of changing these steps again and again in the code where it occurs, we just change it in one place where the function is, and this makes our code really maintainable. I imagine by now you're kind of thinking, okay, it makes sense to reuse the logic, but I don't want the exact same thing to occur. If that was the case, I'd just store it in a variable and call it when I need it. And that's where parameters come in. You'll also hear these called arguments. Parameters or arguments are things that are added to our function, they're injected into the code, and they dynamically change it at runtime. And here we kind of know what's up. We've used the print function, and we often pass an argument in there that's different, that slightly changes the behavior of the print function. Now let's add some parameters to our example to make it more usable. I'm going to copy our say hello function and slightly modify it here. Now I'm going to add a temporary variable name, and then I'm going to use it inside of our function. For instance, I'm going to use a formatted string here and use the variable that we're passing in. And now when I call the function, we can actually change the behavior by adding different arguments here. And that's what makes functions a powerful construct. The behavior of the function is changed by the context in which we call it. I'm going to keep going with this example and make our code just a little bit stronger here. One thing that we can do is actually add defaults. So if a parameter is not passed, we'll have a default value to work with. Now a common case for calling a function may be when we're working with a collection item, perhaps a list. We may have a case where for each item in name list we need to call our function. Now these type of implementation details often come down to our understanding of how a piece of code is going to be used. If we know that we're going to be working with a list, why not just make a function that accepts a list? Let's check it out. Slightly changing our function. we can have it accept a name list, and then we can perform the iteration inside of the function. And using the name list that we defined up here, we're going to pass it directly into this function. Now here, I'm not recommending one approach over the other. I'm just saying that it's up to you, that as part of the design process, you need to understand the requirements for your code and write the best solution for them. If you're a beginner watching this show, don't worry, it's just something that'll come with time. But when I am coding and I'm not sure how exactly I should write something, there is something that I use in Python actually that helps me determine it. You can do this in the shell or wherever you're working at. I say import this, and it prints out the Zen of Python by Tim Peters. Now, I'm not going to go through all of these because I think I could actually spend a lot of time talking through the theory here. But what I'm saying is I like to look at these principles as a reference that I use when I'm designing my own code. I mean, this is what coding's all about, right? It's just as much an art as it is a science. I mean, there's a creative process here with how we implement our code exactly. And like a lot of creative processes, man, a lot of roads go to the same place. So whether you design it one way or another, I mean, that's absolutely up to you. You have that creative control when you're programming. I digress though, let's get back on track. Now, often when we're using functions, we need more than one input. We need multiple things to reference to perform the right logic. So functions can actually accept multiple arguments. Let's take a look at how to do that. I'm gonna write a new function starting with the def keyword. I'm gonna call it hi y'all, and it's gonna accept 3 parameters, name1, name2, name3, then a colon, and this function won't be too complicated, but it is going to print a formatted string. We're going to use all of the variables that we passed in. Howdy, y'all. Now to execute this code, we simply call the function name, and then intuitively here, we pass the number of required arguments. All right, now bear with me. I've been printing a lot of stuff, and sometimes in real code, you do print things. A lot of times, you don't. How do we actually use functions to modularize the logic in our code? To put us on the right path here, let's check out one of the Python standard library functions called float. It accepts an argument and then converts it to a float object. Now, how does the float function work? Thinking through that, obviously there's an argument there. It accepts a parameter, it has some input, and then it converts it into a float object, and it outputs it too. It returns something. I think everyone's seen me do something like this before. I'll take price equals a float, and then I'll print the price. My input went into the float function, and now it's being held in the price variable. Another fundamental principle of functions is that they return a value. We don't always use them as if they're returning a value, but they always return one. For instance, even the print function. I tried capturing the return object with value, and if I print value, we'll see that it actually returned the none object. And this is by default. If you do not specify a return in the function definition, it's just going to by default return a none. To get in the swing of returning objects, let's just write up a function for it. I'm going to say def calc price, and I'm going to use the return keyword. Now let's check out what the output of this function is. And again, it's a none. We didn't actually specify for it to return something. To return a value, all we have to do is put a space after the return keyword with the value that we want to return. And when we call this again, we'll see that our function is returning the object 100. Now we're getting somewhere. Let's just do a few more tweaks to make this a usable function. Let's make it a sales tax calculator like we did at the beginning of this series. We're going to take an argument named price, and then I'll set tax rate equal to 1.0825. Our total is the input price times the tax rate, and my function is going to return the total. Now if I wanted to use this in a piece of code, all I'd have to do is say this price equals calc price, pass in a number, let's say my item costs $80, and then I'm going to print this price. I have the after-tax price of my item. And one of the key features here is that this is reusable. We can perform this operation many times reusing our function. Candidly, guys, I'm not sure why I have this fixation on sales tax price calculators. I mean, this is the sum of my personal and professional work experience. I went to school. Let's get in one more exercise before we put a cap on today's lesson. Let's go back to that whiskey review app that we started in the past couple of videos, and we're going to add a search feature using a function that accepts some user input, searches through the reviews to see if there's a whiskey name that matches, and then prints out the review notes as it usually would. I still have the review app on my desktop. I'm going to edit with Sublime like I like to do. And to add a search, maybe the first thing I'll do is add a user prompt, find reviews. This will be the F prompt. And then I'm going to add another elif to check and see if they're using the F option. And then we could do something like this. Let's say review input equals some input from the user. What review are you looking for? And I want to break my logic out into a function. So here I'm going to write a function called find review, and it's going to take as a parameter this user input. Now I'm going to define my function before this starts running, starting with the def keyword, the function name, and then an input variable, colon, followed by a new line and an indent block where I'm going to write my logic. I'm thinking we could do something like this. Let's start an output variable. It's a list that's going to hold our results. Now I need to find the user's input text in review dictionary. I'm going to perform that with an iteration like for key value in reviewdict.items if our search term review input.upper, to adjust for case sensitivity in the key.upper, then output.append the search result, and this is just going to be a text string, pretty much the same one that we're using down here. This is looking pretty good so far, but let's also handle the case that no results are found. Let's show that to the user. I'm going to go back, I'm going to dedent out of the if, I'm going to dedent out of the loop, make a note to myself that I'm going to check for matches. Really, I just need to check to see if anything's been appended to output. So I can check if the length of output equals 0, let's add an item into it. Output.append, no matches found. And now that our list looks good, all we have to do is return something. Now that the output of our function is fixed up, let's go back to where we called it from. We know that our function returns a list. We're going to hold it in a variable called results. And because we already adjusted for the case in case there are no results, all we have to do is print these out to the user. Now I just need to make sure that my app's still working. I'm going to use R to read the reviews and see what's in there. We got makers, we got Weller. Now I'm going to use the new F option to find something. And I'm looking for, I'm going to go makers. All caps, and we'll see if our case insensitivity works. We got a review for makers. Let's do a find for Weller. We got the review for Weller. And one more time, let's see something that isn't in here. We're going to look for Jim Beam. No matches were found. All right, guys, I hope all that made sense, because now you have another one of those foundational building blocks of Python under your belt. That's all the technical content for today, but I do want to discuss this whiskey a little bit. And the nose on this one is super, super light, like the other Jameson products. On the nose, honey is still the dominant scent, but I'm also getting just a little bit of berry and then like a little bit of ethanol alcohol type of smell in there. I'm taking it to the palate. Now maybe it's because I was working on the Black Barrel last time, but this one seems very toned down, even from the base Jameson offering. It's very, very light on flavor. I'd say that cereal note that I've always found in Jameson is not there anymore. And it's kind of been replaced by some light citrus, like slightly bitter. Let's say grapefruit. That's a weird one, man. I don't know what I think about it. Not my favorite Jameson. I mean, it's not repulsive or anything like that. It's just not one that I'm going to go back for seconds real quickly. They say don't knock it till you tried it. I tried it. I'm not knocking it. I'm just saying I'm not going to be in a hurry to replace this when it goes. That's all for today, guys. As a reminder, I'm asking very gently, if you enjoy this type of content, please consider subscribing to my channel. If you're interested in seeing the source code that I wrote up, I'm going to be putting a link in the description below to my GitHub. And until next time, friends, Tipsy Python.